So, good morning. Welcome to another fun morning of chemistry with your host, me, Dr. White. That's Chem 1105. All right, lots to do today, so I better get started. First place I want to do is let's go to Blackboard. Thumbs up, people. Do you see Blackboard? Test one procedure announcement on your screen. Thank you, thumbs up, people. All right, tomorrow, Thursday at 10 a.m., you'll be taking test number one. Remember, this is a VCM course, not an internet course. At about 9:55 after we do the lab, maybe a little earlier, tomorrow, 7, oh, it's already July 1st. Time's flying this summer. I will email you the password for the version of test number one that you should take. I have two versions this test. Sometimes I do more, but two seems works well. From the assignment area, Blackboard, you'll download test your version of the test for the password that you were sent. Now, if you want, you can download both of them so you're ready for whichever one you get. You will have until 11:30 tomorrow, July 1st, take test number one and upload your answers as a single PDF file to the assignment area Blackboard. If you don't have a printer, you can write the question number and your answer on a piece of paper or pieces of paper, because it'll be probably more than one. And then you make a single PDF file, either with your scanner or your cell phone, to these answers, which you'll upload to the assignment area of Blackboard. I reserve the right to subtract up to 25 points for anyone who does not get test number one uploaded to the assignment area Blackboard on time. Now, if I've given you special permission to be late, I won't take it. But if I haven't, be on time. Also, I reserve to take up to 25 points off for anybody who doesn't upload your answers in a single PDF file. I'm going to be spending a good part of Friday or Saturday grading this test. And I don't need to have someone send me 8 different PDF files. I don't have time to play games like that. So if you don't want me taking off points, follow directions. Now, if you have any questions about this, feel free to ask me. As always, there's no such thing as a dumb question. All right, let's go. What I'm going to do now is switch to student view. I'm in faculty view right now, if you haven't guessed. Now, if you look at the assignment area, oh, look, thumbs up, people. Do you see Chem 1105 test number one? There are the two versions. I have a file. If you don't have a scanner and you don't want to use the method I use in Word, I don't know if it works in a Mac, or I shouldn't say Word in Windows 10, CanScammer is a good app. Do not buy the paid version. Do not buy the paid version. You don't need it. Get the free version. If you notice here, I have a PDF file of a periodic table you can download. It's the green one we've done. Now, the password to open your test number one will be mailed to you tomorrow, but you can download these now and be ready. If you've already been uploading your labs as a single PDF file, at that point, you're ready. So remember, tomorrow we're giving it, and what I will be doing is tomorrow morning we'll have our lab. It's a fun lab, and hopefully you all enjoyed the Beyond Lab Z lab on density. That was fun too. If you have kids, show it to them. They'll love it. You've got a license, doesn't charge you for how many times you log in to be on Lab Z. Now, remember, I will be giving test number 1, and you've got to take it between 10 and 11:30. Also, it says in the email I'll send out tomorrow, but I'll state it now. The password is in all lowercase. When I first started using passwords, I figured, well, if I put upper and lowercase, some students might not catch that, and they're going to be in trouble because the password won't work. So therefore, I make all my passwords lowercase, and you'll get that password. Dr. White has fun making passwords too. All right, any questions about what's going to happen tomorrow with test number 1? I'm looking at the bottom, see if anybody posts anything on chat. All right, let me explain a little about test number 1. After you upload it, because most of the questions are not multiple choice, I think they're about 7, but most of them are not. It's going to take me a while to grade it. Now, also Thursday afternoon, I teach all afternoon, and Friday, I'm having the tree service out to cut down 3 trees and trim 2 others. I've got more trees on my property. So I'm going to be busy a good part of Friday. I want to keep an eye on them and such, but they're pretty, I've been told they're reputable. They come well. This well, I got a brain freeze. But anyways, people like their service. What I will do right now is I promise by this Sunday, 1 p.m. in Blackboard, I will have your test number 1 score posted. Hopefully sometime Saturday afternoon or earlier. When I do that, I will send out an announcement that it's available in Blackboard for you to see. Also, I will send out individual emails to each student, and hopefully by Sunday afternoon, if not sooner. And in each email you will see the points you got for each answer. Now, next Monday is July 5th, which is after the 4th, which is we're going to have a long holiday weekend, and there's no classes, no nothing at COD, online or anywhere else on Monday. I always go through all the answers of many of my tests, all my tests, the next class period, and this will be next Tuesday. And next Tuesday, I will go through every answer and how to get that answer for test number 1. So you can check, what did I do wrong if you got points taken off? Now, I will cut that out of the video. Ooh, how do you like that? I'll cut that out of the video because I don't want those answers floating around the internet for the rest of all time. And therefore, if you can't make it next Tuesday, come to any of my office hours and I will help you and show you the answers for what you got wrong. And that's test number 1 information. Any questions? Any comments? All right, let's proceed. The material, oh, one other thing, because the things are going to speed up now. It happens every summer in July. Next Tuesday, I will go through not only the answers to the test, but I will go through problem set for chapter 4. This finger's broken. Chapter 4 problems. Oh, it's the same thing on this side. Chapter 4 problem set. Make sure you try it this weekend. Test number 2 is coming up soon. Every test is coming up soon. It's summer. All right. Thumbs up, people. Do you see validity check on yours? Thank you, Rain. All right, we're talking about a chemical equation. A chemical equation is a statement that shows a chemical reaction. And if A and B were chemical formulas, these are the reactants at the base of the arrow. Could be only one or more. And sometimes Dr. White, me, will call them the starting materials, because that's how we call them if you work in the chemical industry, which for many decades I did. Now, at the head of the arrow, we call those the product or products. And if I were to write the following, I would ask you first, for this chemical reaction, what are the reactants for the chemical reaction I just wrote? Everybody figured out? Hopefully you did. And what are they? Hydrogen and oxygen are the reactants. By the way, the plus sign is how we use the word and. And this will be hydrogen and oxygen react. What is the product of that chemical reaction? And the answer is water. This is the product. So that's a chemical reaction. Now, important thing, our chemical equation, they must be consistent with the experimental facts. So if you mix oxygen and hydrogen together, you do it, you're going to get water. Otherwise, that chemical equation is wrong. However, you do get water. Now, this is very important. Due to conservation of matter, when you do a chemical reaction, atoms are never created, atoms are never destroyed. When you do a chemical reaction, atoms are never created, never destroyed. And because of that, there must be the same number of atoms of each kind of atom or element on both sides of the equation. And we call that balancing or balanced chemical equation. And a balanced chemical equation has the same number of atoms of each element involved in the reaction on each side of the reaction. Atoms of elements are never gained or lost or changed into atoms of other atoms of elements during chemical reaction. Now, let's look at the following chemical reaction. And I'm going to do it on the whiteboard so I can have more room. And the first question is that balanced? Good question. And how do you determine that? Guidelines for balance. Well, this is how you bring it into balance. But let's go back to this. How do we know if it's balanced or not? You should have the same number. By the way, thumbs up, people. Do you see H2 plus O2 going to water? Thank you. See ya. All right. Notice I have two hydrogens on this side. Oh, I have two hydrogens on that side. I have two oxygens on this side. Uh-oh, I only have one oxygen on this side, because you know how to look at a chemical formula to determine how many atoms you should, especially for tomorrow, you should. Hint, hint, wink, wink, say no more. So this is unbalanced. How do we get it balanced? Well, you cannot change the formula of a molecule. Hydrogen gas doesn't exist as H4. It's always H2. Water does not have two oxygens in it. It only has one. So what do? We change what's called the coefficient. Which I often spell wrong, which would be interesting if I did. And that's the number in front of an element or molecule in a balanced chemical equation. The coefficient is the number in front. When you see no number, the number is 1. So the coefficient for hydrogen right now is 1, oxygen 1, water 1. Well, how do you bring it into balance? Unbalanced equations, an unbalanced equation is brought into balance. There's a word missing here. Uh-oh, the dreaded word theft got my file here. Into balance by adding coefficients, that's the number in front, to the equation to adjust the number of reactants or products molecules present. Remember the torsion balance or teeter-totter analogy. That's the note for Dr. White too, Dr. White. All right, now that I remembered, I can talk to you about it. Now, what is the coefficient? It's the number that is placed to the left of the formula of a substance that changes the amount, how much you have, but not the identity of the substance. The coefficient is always a whole number, otherwise known as exact number, and never a fraction or never a number with a decimal point. Let me say that again. The coefficient is always a whole number, never a fraction, never a number with a decimal point. Now, when you're balancing a chemical equation, write an equation with the correct formulas that I'll always give you. Determine if the equation is balanced. On my test, if I ask you to balance the equation, you're going to have to balance it. I know some instructors say, well, I'll put one down and the answer is it's already balanced. I will never do that on my test or final. If I ask you to balance a chemical equation, guess what? If it's on a test or final, you have to balance it. And then balance the equation one element at a time and check to see if the equation is balanced afterward. And it's practice time, but let me teach you how to do this. So here we have, everybody see water being made by reacting hydrogen, oxygen on your screen? Thumbs up, people. Do you see my whiteboard? Uh-oh, nobody's out there. Oh, thank you. All right, let's do this. Didn't want to do that. All right, how do we get this in balance? Well, if we notice, on this side, I have 2 oxygen. On this side, I only have 1, but I need 2 because you need the same number of atoms and same type on each side. Now, students try and do that, and that's wrong. You can't change the formula, but you can change the coefficient. If I want 2 oxygen, I'll put a 2 there. So now I have 2 oxygen on this side and 2 oxygen on that side, looking good. Now on my right, how many hydrogens? 2 times 2. I have 4 hydrogen. Here I only have 2. I need to get 4. How do I do that? I can't change this number, but I can change the coefficient, and that would be putting a 2 there. And now there's 4 hydrogen. And let's check again to see if it's balanced. I have 4 hydrogen on this side. I have 4 hydrogen on this side. I have 2 oxygen. I have 2 oxygen. And what we now know is the balanced chemical equation is 2 hydrogen molecules react with 1 oxygen. When there's no coefficient, that's really the number 1. We never put it there. We don't need to. Makes 2 molecules of water. And that's the balanced chemical equation. You change the coefficients to make the number of atoms of each type the same on each side of your arrow. You know some? I'm going to let you try one. And this is a fun reaction, as you'll see in a little while. If you react sodium with chlorine gas, Cl2, you make sodium chloride, table salt. Now, we don't do this chemically because most salt we consume for food uses and other uses come from the sea or is mined from underground, or it exists on this planet. But it's your turn. Why don't you balance this chemical equation? And when you're done, give me a thumbs up. See, somebody already is done. I think this works better for this class, using a poll. All right, I think most of you are done. So I'm going to get to work. Now, how do you know this is not balanced? Because if you look at the chlorine, there are 2 chlorine here, but there's only 1 chlorine here. And to be balanced, there has to be 2 chlorine. So how do we get this to 2? You can't put a 2 there. That's a molecule that doesn't exist, but I can change the coefficient. Right now it's 1. And if I put a 2 there, let me give myself some more room here. If I put a 2 there, now I have 2 chlorine. But now I have on this side 2 sodium. How do I get 2 sodium on this side? Put the coefficient in front of sodium, Na, to 2. And now I have 2 sodium, and let's do a final validity check. Or it's just like balancing your checkbook, which I hate to do, but for balanced chemical equations, this works. 2 sodium, 2 sodium, 2 chlorine, 2 chlorine. Yay, it's balanced. And that's how you do balanced equations. We're going to do some more, but first, a little treat from Dr. White.
This reaction can be safely demonstrated in school. In this case, chlorine has been placed in a flask, and some sand is used to protect the glass from the heat produced in the reaction. A long syringe needle has been used to pick up a small piece of sodium, and using the glass tube, it is dropped into the sand. The syringe is then used to deliver a few drops of water, which causes the sodium to ignite and then react with the chlorine. The product is sodium chloride, which appears white only when excess chlorine has been removed from the flask.
Did everybody enjoy that? I did. Did everybody see that? Thumbs up, people. Did you just see the video, YouTube video? Thank you. All right. If you haven't figured it out by now, organic chemists, when they were little, like pyrotechnics. And that was beautiful. I'm happy now because it was fun to watch. And that was the reaction of sodium with chlorine, that you just balance the equation. And it's quite, you'll teach you later, exothermic. That means it gives off a lot of heat. And that's not a way to get salt for your daily diet, but it was exciting. All right, let's continue on. There are a number of things I want to teach you. Ooh, that reminds me. Balanced chemical equations are an important part of chemistry. On test 2, there'll be 12 points out of 100 on balancing equations. And on the final, there'll also be about 12 points for balancing chemical equations. It's that important. So make sure you know how to do it. I think it's 12-9 or 12. I forgot. I've got to write the final next week or two, trying to get ahead of the game. All right, let's look at some important practical knowledge on how to balance chemical equations. Now, let's look at the following equation. By the way, C3H8 is propane. And that's the gas you buy in the white tanks for your barbecue. And how does your barbecue work? After a spark, the oxygen in the air reacts with the propane to give off carbon dioxide water, and you don't use it for balancing, but you get heat. And that heat is what cooks your food. And this is called combustion. Now, the question is it balanced? Well, let's look real close. How many carbons on this side? 3 carbons. How many on this side? 1. Uh-oh, it's not balanced. How many hydrogens on this side? 8. 2. 3 oxygen. 2. Remember, you count all the atoms from each molecule on each side. So this is not balanced. Now, I don't have a slide for this. I should. One day I'll stop being lazy. Sorry, but listen carefully. I'm going to teach you some basic tips that help you balance equations and make your life easier. Tip number 1, leave hydrogen and oxygen atoms last. Again, leave hydrogen and oxygen atoms last. It works for me. It's worked for many, many years, and it works for all the students who I've had. When they do that, it makes your life easier. So if I'm looking at this period, at this balanced equation, I'm going to leave hydrogen, oxygen last. That means I'm going to do carbon first. If I have 3 on this side, how do I get 3 on this side? Well, I can't change the formula, but I can change the coefficient. So now I have 3 carbons on both sides. If I look, all I have left is hydrogen and oxygen. So if I'm going this way, I'll do hydrogen next. This side, I have 8 hydrogen. I only have 2 here. How do I get that to 8? 4 times 2 gives me 8 hydrogen. And now I'm left with oxygen. On this side, I have 2 oxygen. How many on this side at the head of the arrow? Well, I have 3 times 2, that's 6 oxygen. And I put a dash there so you know it's not the number 60. Plus, here, how many oxygen here? 4 times 1. And that's 4 oxygen. If I add them together, I have 10 oxygen on this side. How do I get 10 oxygen on this side when I only have 2? I can't change the number 2, but I can change the coefficient. And if I put a 5 there, it will be 10 oxygen. 5 times 2, 10 oxygen. So now I'm going to do my check, just like balancing your checkbook. I have 3 carbons, 3 carbons, 8 hydrogen, 8 hydrogen. Ooh, 10 oxygen, 10 oxygen. Success. We balanced it. You know something? I want you to have some fun too. But before I do, let's go review what I just did for some tea. And what I first did was say, oh, hydrogen, oxygen, and other things, I'm going to leave hydrogen, oxygen last. So the other thing is, in this case, carbon. You check on each side how many they are, and then you adjust the coefficient, the number in front, to make it the same. 3 carbons here, there was only 1, so I put 3 in front of CO2, carbon dioxide, and now I have 3 carbons. And all I have left are oxygen, hydrogen. And I said, I'm lazy, I'm going this way, I'll do hydrogen next. I have 8 hydrogen here. I only had 2. How do I get that to 8? I changed the coefficient to 4. It was 1. So 4 times 2, 8 hydrogen. That's done. Now on this side, before I put the coefficient there, when it was 1, I had 2 oxygen there. How many on this side? Well, I have 3 times 2 is 6, and 4 times 1 is 4. Add them up, 10 oxygen. How do I get 10 oxygen on this side? 5 times 2 is 10. And then I check to make sure 3 carbons, 8 hydrogen, 8 hydrogen, 10 oxygen, 10 oxygen. And that's how you do it. Remember Dr. White's advice for these type of reactions, leave hydrogen, oxygen last. So in that case, I'm going to let you have some fun. And why don't you balance the following chemical equation? 3 points each. On a test, I would write down this, and this might be A. So have fun. Remember, follow my advice, leave hydrogen, oxygen last. And sometimes this takes a little while to do, especially if you're new to it. You're all some of you are rookies. All right, it looks like everybody's done, so I better get to work. How do you know if it's balanced? Well, it's not, because there's 5 carbons here and there's only 1 there. There are 12 hydrogens too, and same thing with oxygen. So I'm going to follow my advice. I'm going to leave hydrogen and oxygen last. So I'm going to start with carbon. There's 5 carbons here. How do I get to 5 carbons here? I changed the coefficient to 5. Coefficient, I'll never ask on a test, but I'll use the term, the number that goes in front of molecules or elements in a balanced chemical equation. Well, now I have 5 carbons, and I'm still being lazy, so I'll do hydrogen next. You could do oxygen, but I'm lazy. 12 hydrogens there. Uh-oh, I only have 6. 2, how do I get that? I'm getting ahead of myself in my mouth and brain. But how do I get that to 12? Put a 6 there. 6 times 2, 12 hydrogen. And now all we have left is oxygen. This side we have 2, but how many oxygen on this side? 5 times 2 is 10 oxygen, plus 6 times 1 is 6 oxygen. Add it up together and you get 16 oxygen. And how do we get this side to be 16 oxygen? Well, what is 2 go into 16? How many times? Get your calculator out. 8. And now we have 16 oxygen. And I see a question or a comment. Hold on. It was both somebody got it right. And how did I get to 16 oxygen? Good question. All right. On this side, the product side, you count all the oxygen atoms. From this molecule, how many oxygens are in there? 5 times 2, which is 10 oxygen. In the water, how many oxygen are there? The coefficient 6 times the number 1 gives me 6. And then you add those two together. Hopefully I did that right, and I think I did. And that's how you got 16. And does that help you? Does that help everybody? Remember, on each side, you want the total number of atoms, not just from one molecule, from all of them. Well, that's why to everybody, that's why I say there's no such thing as a dumb question. All questions are good questions, because that's why you're here, to learn. And asking questions helps you learn, as I just proved. All right, now let's move on to another type. And let me get back here. I didn't do my check. Shame on Dr. White. Here we have 5 carbons. Here we have 5 carbons. Here I have 12 hydrogen. Here I have 12 hydrogen. Here I have 16 oxygen. Here I have 16 oxygen. Yay, we're balanced. So it's a balanced chemical equation. Now there's certain situations where there's I don't know if it's a procedure or a trick. And one of them I call even odd. Hopefully you all know what an even number is, and you know what an odd number is. And let me show you an example of what I call an even odd situation when you're balancing chemical equations. Now, here we have a chemical equation. Hopefully everybody sees it. If you take iron, Fe, it reacts with oxygen, like what's in the air, to make ferric oxide, which is rust, which you don't want to happen on your car, but that's what happens. Is this balanced? Let's find out. Oh, look, we got 2 iron here, but only 1 here, 2 oxygen, and 3. Now, why do I call this even odd? Because I'm going to look at the oxygen. And the problem is there's nothing I can multiply 2 by to get the number 3. There's nothing I can, a whole number. Remember, coefficients are a whole number. There's no whole number I can multiply 3 by to get the number 2. So what do? Here's the trick. Take the number of atoms on this side, 2, and multiply it by this side, 6. And both 2 and 3 will go into 6 to give you whole numbers, exact numbers. So how do I get 6 oxygen on this side? Put a 3 there. How do I get 6 oxygen there? Put a 2 there. Now, 2 times 2, I have 4 iron on this side. How do I get 4 on this side? Put a 4. And now let's check. 4 iron, 4 iron, 6 oxygen, 6 oxygen. Again, the problem is coefficients are always whole numbers. Again, coefficients are never fractions. They're never decimals. They're whole numbers. And you'll learn also later in the semester, they are, well, I'm teaching it now, but we'll use it later on. They're exact numbers. So how do you get 2 numbers to be the same number of atoms when one's even, one's odd? You do the trick I just taught you. Multiply the 2 times each other and then divide, that's how many atoms you need, and then change the coefficient to get that, and balance everything else afterward. And that's even odd. And let me give you an example to try on your own. If you take sulfur reacted with oxygen, you get sulfur trioxide. Your turn, balance it. Remember the even odd trick I just taught you. And that's SO3, not a 5. That's better. Well, somebody's already sent me an answer, and I'll ask that person to wait because I'll go through it. The one bad thing about teaching on Zoom when nobody has their cameras on is I can't see if you're done or not. When I'm in a classroom face to face, I can look around and see the students are looking at me, they're done. So I'm going to use the poll again. I think everybody's done, so I'm going to get started. Get to work. Now, how do you balance this? Well, there's one sulfur here, one here. Oh, there's two options here and three there. And there's nothing I can multiply whole numbers 2 by to get 3. There's nothing I can multiply whole numbers 3 to get 2. So again, this is what I call even, odd. And how do you do that? Well, 2 times 3 is 6. How do I get 6 oxygen here? I change the coefficient to 3. How do I get 6 oxygen here? I change the coefficient to 2. So these are done, but now I have 2 sulfur here, only 1 here. What do I do? You change the coefficient to 2, and now you have 2 sulfur. Again, you change the coefficient, the number in front, to give you the amount of atoms you want. So let's do our check. 2 sulfur, 2 sulfur, 6 oxygen, 6 oxygen. It's balanced. That means 2 sulfur reacts with 3 oxygen molecules to give you 2 sulfur trioxide molecules. And that's how you do even odd. Now, if I look at the clock, I'm going to let you take a whole longer break, an extra minute and a half longer. Why don't we all come back at 9:55, and I'm going to go stretch, and I'll see you in about 5.5 minutes. time to get started. But first, a little public, I don't know, service announcement, nothing to do with chemistry, but, and you can ignore it if you want, but if you're not reading Paul Krugman's, Dr. Krugman's Twitter account, he's Nobel laureate and also has a column in the New York Times, and through COD, you can get free access to New York Times. You should. I just saw his recent post here, which I read. I check it a couple times a day. He does a lot of good stuff. All right. It's time to put everything you just learned together, and I'm going to show you a little more complex balancing a chemical equation, and we'll put together everything you just learned. All right, if we look at the following, is it balanced? The answer is no. On this side, I have 2 iron. Over here, I just have 1. Here I have 3 sulfur. I just have 1 there. And I have 1 potassium. Here I have 2, and I got everything else not balanced. So you have to balance it. How do you balance? I'll do this one, and I'll give you one to try too. You leave hydrogen, oxygen last. So if I'm going this way, on this side, I have 2 iron. On this side, how do I get 2 iron? I do that. Change the coefficient. Now next, how many sulfur? 1 times 3. I have 3 sulfur. How many on this side? Only 1. How do I get that to 3? Well, you put a 3 in front, and now I have 3 sulfur. Now, oxygen, oh, Dr. White says leave those to last. All right, I will, because I'm going to skip this. And the next is potassium. I have 1 potassium. How many on this side? 3 times 2 is 6 potassium. How do I get 6 on this side? I put the coefficient 6. And now all I'm left with is hydrogen, oxygen. So I'm going to do oxygen first. How many total oxygen on this side? 4 times 3 is 12 oxygen, plus 6 times 1 is 6 oxygen. And if I do the math right, that's 18 oxygen. Now, if I go on this side, how many oxygen on this side right here? 3 times 4 is 12 oxygen. Ooh, 2 times 1 times 3, because this is 1 times 3, there's 3 oxygen, times 2 is 6 oxygen. Ooh, looking good. That's 18 oxygen. And the only thing I have left is hydrogen. How many hydrogen on this side? 6 times 1, 6 hydrogen. How many on this side? There's 1 times 3 times 2. So 2 times 3 is 6 hydrogen. And now I'm going to check, did I really balance it? And the answer is, we'll find out. 2 iron, 2 iron, 3 sulfur, 3 sulfur, 6 potassium, 6 potassium, looking good. 18 oxygen, 18 oxygen, and 6 hydrogen, 6 hydrogen. We did it. It's balanced. And that's how you do that. Remember, you can't change the chemical formula, but you can change the coefficient, the number in front. So I'm going to share the fun and let you try one. If you take aluminum and react it with sulfuric acid, H2SO4, you get aluminum sulfate plus hydrogen. This is not balanced. You have to do it. Your turn. It's time for you to have some fun. If you're having difficulty, don't forget, most of you are rookies at this. So good news, I have practice problems for you for this chapter, balancing chemical equation, and a whole lab will be devoted to balancing chemical equations. So you're gonna get a lot of practice. And when you're done, give me a thumbs up or I'll send out the poll. And I see some people already putting up answers. I'll do it in a second. So you'll find out, did you do it right? See what a nice person I am? I am, I hope. All right, I think everybody's done. Time for Dr. White to do it. And once in a while, I even get mixed up. Rarely, but it might happen. All right, let's balance it. My advice, leave hydrogen and oxygen last. So aluminum, 1 there. Uh-oh, there's 2 aluminum there. Hold on. There are 2 aluminum here. How do I get 2 on this side? Change the coefficient. So now there's 2 aluminum. Oh, hydrogen, but Dr. White says leave it last, so I'm going to follow my own advice, and I'll do sulfur. There's 1 sulfur. Oh, how many on this? 1 times 3. There's 3 sulfur on this side. How do I get this side to 3? Put the number 3 in front. 3 times 1 is 3 sulfur. All right. Well, the only thing left is hydrogen, oxygen, so I'll do hydrogen. How many hydrogen on this side? 3 times 2. That's 6 hydrogen. Oh, there's only 2 here. How do I get it to 6 hydrogen? Change the coefficient to 3. 3 times 2 gives me 6. And the last thing I have to do is oxygen. 3 times 4. Ooh, that's 12 oxygen here. How many on this side? 4 times 3. 12 oxygen. I think I'm done. Let's find out. 2 aluminum. 2 aluminum. 3 sulfur. 3 sulfur. 12 oxygen. 12 oxygen. And 6 hydrogen. 6 hydrogen. We did it. It's balanced. And therefore, you react 2 aluminum with 3 sulfuric acid, H2SO4, to make 1 aluminum sulfate and 3 hydrogen molecules. And that's balanced chemical equations. Now, there's an important concept or aspect that I need to talk about. And let's go back to the first equation we did. And 4, 4, 2, 2. Now, this is balanced. What if you wrote this down? Now, if you check, you have the same number of atoms on each side, but this is not considered correct because otherwise saying wrong. Because if you can divide all the coefficients by the same number and get a whole number, then you should. These numbers should never be a multiple of the same number. Again, if you can divide all the coefficients by the same number and get whole numbers, then they should never be multiples. And this is the correct one. Because if I divide each one of these by 2, it will take me to that. And the same thing, I could have done this. And this would also be wrong because I can divide all these by number 3, which would again bring me up here. So you always make sure your coefficients of your final answer, you can never divide all the coefficients by the same number and get a whole number. And if you can do that, because that's important. And this is a common mistake. And if you were to write this and this, I would do this. 0 points, where this one would be 3 points because it's correct. And that's an important thing I wanted to teach you. Any questions about how to balance a chemical equation? Looking at the chat. Remember, I have a problem set. Thank you, Jada. I'll also have a lab, and you're going to have plenty of practice. Remember my advice. Always do hydrogen, oxygen last. That's been working for me for many years, and it's been working for my students for many years. So do that. Remember the even odd I taught you. And remember, you never want the coefficients to be able to divide all of them by the same number to get whole numbers. If you do, divide it and get that. All right, it's time to move on. Oh, thank you, Jada. It should be easy once you follow Dr. White's advice. Oh, I should tell you, everybody, is everybody watching me? Hold on, I'll get your attention. Did I get your attention? Everybody, take a deep breath. Let it out. I don't want nobody turning blue on me. Take a deep breath. Let it out. Are you relaxed? Stay relaxed. Next part of this chapter in the semester, we're going to be doing some algebra. Relax. I'm going to teach you everything you need to know how to do that. I'm going to teach you how to solve problems, but you're going to do some math, but you'll see I'm going to teach you something about my good buddy, my good friend, unit analysis. So we're going to do some math, but relax. Students get it. And if you don't, come to my office hours or after lab. All right. Dr. White's going to have fun because I love this area. And that's the mole. What is a mole? Well, a mole isn't a furry little animal that digs holes in the ground in chemistry. The mole is the chemist counting unit, or counting unit used by chemists. Oh, I think I better be subtle. You should know what a mole is. It's the counting unit used by chemists. And one definition of a mole that you should also know is a mole contains 6.02 times 10 to the 23rd things. And this number, 6.02 times 10 to the 23rd, is Avogadro's number. And you should know that. Now, I used to make students memorize that, but I give that to you, you'll see later on for test number 2, important information. So a mole is the counting unit used by chemists. And a mole, when we say a mole is something, we're talking about 6.02 times 10 to the 23rd, whatever. Speaking about whatever, I better bring up a personal something about Dr. White. Near the end of December is my birthday, so you got plenty of time. And you know what my favorite all-time birthday gift would be? First of all, tea is not my all-time favorite gift. What I'd really like for my all-time favorite birthday gift is a mole of pennies. Is this pennies? Give me a mole of pennies. What is that? I figured out one time. It's 100 million piles, and each pile has $1 billion in pennies. But it's just a mole. And just like you say, a dozen is 12, a mole is Avogadro's number. So don't forget, my birthday is coming up. And if you can, get me a mole of pennies. I think I figured out that would be all the money that's on the planet right now, that was on the planet, and that will be on the planet. But it's just a mole of pennies. A mole is a huge, huge, out of my screen focus area, huge number. End of December, for those who are wondering. And you got plenty of time to save. Just a mole of pennies. All right. So you should know a mole is the counting unit used by chemists. And a mole is Avogadro's number. Now, Avogadro did work. He wasn't the one who came up with this number, but because of the work he did that helped establish the basis that the people who did come up with the number could, that's why it's named after him. Avogadro's number I believe Italian scientist. I don't think they called it chemist then. Hold on one second. Don't you love Google? And there you see the many significant figures. Everybody see this on their screen? There's a picture of him. Now that looks ancient. He looks ancient. Well, he is. And here's Avogadro's number. It's the number of particles contained in 1 mole. Must be true, it's in Wikipedia. But I should point out, and I think I mentioned it, that Wikipedia has been so heavily policed by chemists, including myself, that it's been years since I've seen any kind of major error in a chemistry Wikipedia entry. I don't know about other stuff. And he lived until what, 1860. So notice this number is a little different than what I gave you because I'm using 3 significant figures for Avogadro's number. It's a calculated number, not a definition. And if you want to learn more about it, you can read this at your leisure. Now, this is Avogadro's number. An important thing is 1 mole equals 6.02 times 10 to the 23rd things. This is a definition. 1 mole of anything equals Avogadro's number. Now, I need to teach you some important things that will help you the rest of the semester. And let's assume we have A equals B. When you have this equals something else, there are 2 ratios that are possible. One is A divided by B and not equal, and the second ratio is B divided by A. And that's always going to be true. So whenever you have something equals something else, there are 2 ratios that you can develop or obtain from this equation, or I guess it's an equation, mathematical equation. Well, if we look at 1 mole of whatever equals Avogadro's number, then there are 2 ratios I can have. Now I'm going to teach you how you don't have to memorize this, but I want you to understand this exists. So when we get back to chemistry, well, we don't talk about things. In this class, we talk about atoms and molecules. And therefore, you should know. In the past, I made students memorize this. 1 mole equals Avogadro's number in either atoms or molecules. And you have 2 ratios like that. Let's now let me show you 2 things you should know. One mole of an element equals Avogadro's number of atoms of the element. One mole of an element equals Avogadro's number, which is a lot of atoms, but it does. Next, you should know 1 mole of a compound equals Avogadro's number of molecules of that compound. So if I said, oh, look, I have a mole of gold. Well, gold is an element. How many atoms of gold do I have? 6.02 times 10 to the 23rd atoms of gold. If I said I have a mole of lead, how many atoms of lead do I have? Your turn to think about it. Time's up. 6.02 times 10 to the 23rd atoms of lead. Now, what if I said I had a mole of water? And the question be, how many molecules are in 1 mole of water? And the answer is now 6.02 times 10 to the 23rd molecules of water. Again, 1 mole of a compound is equal to Avogadro's number, 6.02 times 10 to the 23rd. I should point out this is 3 significant figures. Hopefully you all figured that out. It's a calculated number. Therefore, Avogadro's number, 1 element, equals Avogadro's number, 6.02 times 10 to the 23rd atoms. 1 mole of a compound equals Avogadro's number, 6.02 times 10 to the 23rd molecules of a compound. Now, good news, as you've figured out by now, because I told you, I have cut down the memorization in this class a lot. Because a year and a half, maybe 2 years, a couple years ago, another faculty member challenged me with the concept, are you teaching chemistry or testing chemistry when you give a test, or are you testing chemistry and a person's memory? I said, I should be teaching chemistry, testing chemistry, how much you've learned, not how good your memory is. And because of that, I changed how I taught this class and other general chemistry classes. In the past, students had to memorize 1 mole of an element equals Avogadro's number of atoms of the element, and 1 mole of a compound equals Avogadro's number, 6.02 times 10 to the 23rd molecules of that compound. Good news. I'm putting that important information. Test number 2 will also be on the final. And if you look in the lecture folder of Blackboard, I already have posted important information, test number 2. And notice I have 1 mole of an element equals Avogadro's number, 6.02 times 10 to the 23rd atoms of that element. And I have 1 mole of a compound equals 6.02 times 10 to the 23rd molecules of a compound. And you don't have to memorize that, but you do have to know how to use that. And how do you know how to use that? It's time for me to teach you about my good buddy, my good friend, unit analysis. I was taught this by in high school, the AP teacher, advanced placement, which was college level chemistry, I took in high school my senior year. Mr. Salner's guy, I still remember, he did such a great job teaching. I've been blessed. I've had a lot of great teachers when I was in high school, college, and grad school. I should say undergrad, but college and grad school. And Mr. Salner's beat into our brain unit analysis. He didn't come up with your good buddy, your good friend, but he implied it, and it is. And I should warn you, between now and the end of the semester, I'm going to be going for the Guinness Book of World Record for saying the most times in a chemistry class in one semester, you're a good buddy, you're a good friend. And it is, has been mine for, I hate to say this, decades. How does that work? Well, let's do some mole practice time, including your good buddy, hold on, your good buddy, your good friend, unit analysis. Well, how do you do that? Well, let's look. All right, haven't done it in a while, but I better. Thumbs up, people. Do you see 5 points? How many atoms, Ag, which is silver, are in 5.11 moles of silver? Thank you. Now, watch closely. Not only will I show you your good buddy, your good friend, unit analysis, I'll show you how to approach word problems. Relax. These are word problems, but my approach helps students. The first thing I'm going to do, besides make a line that I shouldn't have, is find out, read the problem, and say, what am I being asked to find? And write that down. I don't know where I started this, but question mark, atoms of silver. Next, I'm going to read that. What am I given? I have 5.11 moles of silver. Well, the only thing I have to start with is this, so I will. Now, if I had a magic ratio, this is part of unit analysis, what units do I want my answer to be? Well, I figured that out right here. I want my answer to be in atoms of silver. And now it's time to use your good buddy, your good friend, unit analysis. And how do you do that? And we're going to practice it a lot, but watch. Whatever you're trying to get to, the units go on top of the ratio. Whatever you're trying to get to, the units go on top of the ratio, and I'll write it in a second. Whatever you're trying to get rid of, I don't want moles of silver in my answer, goes on the bottom of the ratio. Now, couple things. Remember, for this one, we have atoms and moles, and you should know 1 mole of an element, and this will be given to you, equals Avogadro's number of atoms of the element. So if we come back here, what do I want on top? Atoms of silver. What do I want underneath? Mole of silver. And where do I get these numbers? 1 mole of an element equals Avogadro's number of an element. Now, the next part of unit analysis is check. Do the units, don't pick up your calculator yet, do the units cancel out? So when I do this multiplication, division, I get atoms of silver. And if we look down here, you don't have to write this down like I'm going to do, but I just want to show you the mind thought process. If we look up here, what units do I have? Moles of silver times atoms of silver divided by moles of silver. Now, let me remind you, anything divided by itself equals the number 1. Let's see if I'm lying to you. If you take 2 divided by 2, what does that equal to? 1. Anything divided by itself gets the number 1, and we call that canceling out. So moles of silver divided by moles of silver will be the number 1, which essentially 1 times atoms of silver will be atoms of silver. So I can say this divided by itself, unit-wise, cancels out. And notice all I'm left with is atoms of silver. So now I can pick up my calculator, and I am. I have 5.11 times 6.02. Don't forget to use the second key, double E, to get to 23. And I'll hit enter. And the number my calculator gives me is this. There's a decimal point there. 307,622 times 10 to the 24th. Now, on test number 2, and it'll be on test number 1 also, it says please use proper significant figures for all calculated answers. So remember the rule for multiplication division. You get the same number of significant figures in your answer that the number you're multiplying dividing has the smallest number of significant figures. You get the same number of significant figures in your answer that the number that has the smallest significant figures they're multiplying dividing. This is 3 significant figures. Avogadro's number is 3 significant figures. Now this 1 is part of the actual definition, so this is an exact number and it plays no role in significant figures. So our answer should have 3 significant figures. So I have to round that off. How do you do that? Keep the 3, keep the 0, keep the 7. Those are all significant figures. Remember, 0 after decimal or 0 confined, in this case it's both, is significant. So this is a number to round off. So have 4 or less or 5 or greater, 5 or greater. That means I'm going to drop this and increase that by 1, and the correct answer would be 3.08 times 10 to the 24th. And that's how you use your good buddy, your good friend, unit analysis. Now, I know some instructors make you memorize all the ratios. No, just learn your good buddy, your good friend, unit analysis, and that will help you. Let's do another one. I see a question or a comment. And someone asked, could we go back? And the answer is yes. Also, don't forget, you can always watch instant replay later today or early tomorrow, usually it'll be later today, of the video on Dr. White's Chem 1105 YouTube channel. I also have a Chem 1211 and a Chem 1212 YouTube channel. You're welcome. Remember, Dr. White has a fast mouse wheel finger. All right, let's do this next problem. How many? Oh, let's use moles of water. By the way, I shouldn't point out in your book, they write mole this way. Dr. White uses the old way. I think it looks better with the E present. I don't know why they dropped the E, but I don't. All right, I'm going to do what's called fading prompts in education. Ooh, fancy stuff here. And the question is 5 points. How many moles water, H2O, are 4 point, I could have put R in, either way works, in 4.311 times 10 to the 42 or 42nd molecules of water. Now, what I'd like you to do right here is write down what are you being asked to find and what are you given. Write down what are you being asked to find and what are you given. Then I'll do the math part, but I want you to try that part first. All right, let's take a look at this. What are you being asked to find right here? How many moles of water? By the way, I apologize. I write moles more than I print it. And what are you given? And once you've figured that out, you never have to look at this again because you're all set to go. And what does it mean, set to go? It's time to use your good buddy, your good friend, unit analysis. And how do we do that? Well, this is the only number we have. Don't forget to put the units down too. Otherwise, unit analysis won't be your good buddy, your good friend. Now, if I had a magic ratio, what units do I want my answer to be in? Well, you already figured it out right here. I want moles of water. And now it's time to use your good buddy, your good friend, unit analysis. I love that. And how do you use your good buddy, your good friend, unit analysis? Whatever units you're trying to get to goes on top of the ratio. Whatever units you're trying to get rid of goes underneath. So I'm going to write that in right now. I want moles of water on top, and I want molecules of water underneath. And where do you get these numbers? You know 1 mole of a compound equals Avogadro's number 6.02, 10 to the 23rd molecules Doctor, you know how you have a bad hair day? Dr. White is having a bad whiteboard day, which is rare, of the compound. And remember, whenever you have A equals B, there are two ratios you can always have, A over B and B over A. So if I look here, for every 1 mole of a compound, water, I have Avogadro's number of that. Now, before I pick up my calculator, do the units cancel out to leave me with molecules of water or moles of water? And notice molecules divided by molecules cancel out because A divided by A equals 1. Now, let me show you something how you can tell when you did it wrong. What if you wrote it this way? Don't, but if you wrote this backwards, the ratio upside down, when you look at your answer, it would be molecules of water times molecules of water divided by moles. Nothing cancels out. You don't want that. And that tells you, oh, I made a mistake. And that's how you use your good buddy, your good friend, your analysis. Now that I've checked up here, my molecules check out. I'm just left with moles of water, which is what I want. I will pick up my calculator and 4.311 times 10 to the 42nd divided by Avogadro's number 6.02 times 10 to the 23rd. My calculator gives me this number. I see a question. That's a 42 right up here. This is 4.2. Let me show you something. Sorry about that. And if you're not sure, this is a 2. I always write my 7s like that, always. I've been doing that since high school because I think it's cool. Dr. White tries to be a cool dude whenever possible. All right, does that help? And all questions are good questions. Now, on, and this should be a 1 right here. It should be 7.61. Hold on, let me clean this up a little. 1129568 times 10 to the 18th. And how do you round this off? Is this the correct number? No. On test number 2, like test 1, will say, please use proper significant figures for each answer. And by the way, Lily, you're welcome. All questions are good. So I'm going to let you figure out how many significant figures, what should your answer now really be? I'll give you 8 more seconds. And the answer is, let's take a look at this. This is 4 significant figures. This is 3 significant figures. This is something you need to know for tomorrow. And therefore, when you do this is an exact number. When you look at this, your multiplication division, you get the same number of significant figures in your answer as the answer that has the lowest significant figures, which in this case is 3. Round this off to 3. 1, 2, 3. The number I round off is 1, is 4 or less. I'm going to drop all that. So the correct answer is 1.6 times 10 to the 18th moles. That's a lot of moles of water. And with that, guess what? I went a whole minute over, so come back at 10:51, and I'll see you then. You got to do a division, not, remember, this is a division. And where are we? This is 10 to the 42nd divided by 10 to the 23rd. If you forget about the number in front of that, that would be 42 minus 23, which is what I did was right. I think you multiplied, not divided. Disha. All right, I'm going to take a break. I'll see you back in about 5 minutes. Time to get going. All right, everybody back? Give me a thumbs up. Oh no. All right, I see a lot of thumbs up, so you're all ready to get going. So I better get going. Now, let's review how you use unit analysis. And also, how do you take test questions in chemistry, my chemistry? And if I asked you how many moles of water are in 4.311 times 10 to the 21st, 10 to the 42nd moles of water, you find out what you figure out. What are you trying to find? What are you given? You're given 4.311 times 10 to the 42nd molecules of water. You start with that. In using your good buddy, your good friend, unit analysis, you have a ratio. And then on the other side, you have what units are you trying to get to? And that's moles of water. And how do you use your good buddy, your good friend, unit analysis? Whatever units you're trying to get to goes on top of the ratio. Whatever units you're trying to get rid of go underneath. And then where do you get the numbers? Well, you look, where do you have a relationship of moles of water and molecules of water? And that relationship is 1 mole of a compound equals Avogadro's number, 6.02 times 10 to the 23rd molecules of that compound. Therefore, if I put the 1 here, 1 mole, remember when you have A equals B, there are 2 ratios, A over B or B over A. In this case, it's A over B. You don't have to memorize it because you know 1 mole compound would go of the water goes here, and Avogadro's number, 6.02 times 10 to the 23rd molecules of water goes here. Molecules of water divided by molecules of water equals 1. A divided by A is 1. Cancels out, and you're left with the right units, and you use significant figures. And that's how you use your good buddy, your good friend, unit analysis. So I'm going to let you try one. Oh, I promised I'd print. And important information you would see one mole of a compound equals Avogadro's. That wouldn't be a problem, but I'm going to help you out a little. Yes, that's HCl, H and C in a lowercase l. And you don't have to be sorry for asking questions. And why don't you figure out what are you being asked to find, what are you given, and then use your good buddy, your good friend, unit analysis. You don't have to calculate a number, just set it up. Oh, I forgot something important. The question mark. Don't forget to use your good buddy, your good friend, unit analysis. Oh, by the way, there's a newer name. They call it dimensional analysis. I like my name, the older name, better. And when you're done, give me a thumbs up. Oh yeah, I forgot. This class is, I don't want to use the thumbs up emoji. I'll send out a poll in a little while. All right, I'll give you another 35 seconds. All right, let's do this. Now, the first thing when you read a problem, I'd highly recommend, figure out what are you being asked to find in units. And the answer is how many molecules of HCl. So we were trying to find, and I don't know when I came up with the idea of question mark, but I've been using it for a long time. How many molecules HCl, that's what you're being asked to find. What are you given? How many moles of HCl? And once I've done this, I don't have to look at this anymore. I'm done with that because all the information I need is right here. And now I'm going to use your good buddy, your good friend, unit analysis. And what do I have to start with? This number. That's HCl. And if I have a ratio to multiply this number, what units do I want my answer to be in? Well, you figured that out. And now it's time to use your good buddy, your good friend, unit analysis. How do you do that? Whatever units you're trying to get to, go on top of the ratio. Whatever units you're trying to get rid of, go underneath the ratio. And I'll do that. On top, I want molecules, HCl. Underneath, I want moles, HCl. And where do I get those numbers? Right here from this statement. 1 mole of a compound equals Avogadro's number. You should know what Avogadro's number is. 6.02 times 10 to the 23rd molecules of that compound. So for every 1 mole of hydrochloric acid, that's what HCl is, I have 6.02 times 10 to the 23rd molecules of HCl. Now, before I pick up my calculator, I'm going to check my units. Notice I have moles of HCl divided by moles of HCl. And anything divided by itself equals number 1, meaning it's canceled out. And I'm left with molecules of HCl, which is what I want. So now I feel confident I can pick up my calculator and put the numbers in. Give me a little while. And my calculator gives me this following number. That's a 5.61184 times 10 to the 24th. Now, I'll let you figure out how to round that off and what's the correct answer. Well, I fixed this ugly looking 5. That's better. Give you 4 more seconds to figure out what should that be rounded off to. 7. Time's up. How do you figure out how many significant figures your answer should be? You look at each of the numbers you're multiplying divided, and this has 4 significant figures. All non-zero numbers are significant. This has 3. Remember, 0 after a significant figure, after an integer, after decimal, and 0 confined is significant. This is an exact number and plays no role in the calculation. So this is 4. This is 3, which number is smaller? 3. So we now have to round that out to 3 significant figures. I'll give you 3 seconds to do that. A few more. Time's up. Keep the 5, keep the 6, keep the 1. That's my 3 significant. Use the next number to round off. Is that 4 or less or 5 or higher? 4 or less. So I drop all this, and the correct answer would be 5.61 times 10 to the 24th molecules of HCl. And now a public service announcement from Dr. White. On every test, most of the questions are not multiple choice. Why? One, when I was a student, I hated them. Luckily, they didn't have Scantron as much wide like now, so they were pretty rare, but I still hated them. SAT, ACT, oh, I hated those. GRE, oh, I hated that. That's a graduate record exam. It's like the SAT, but for you to get into grad school. But anyways, because I have, you got to calculate something, just not pick a multiple choice. If you show your work and you make a mistake, I can track it down and I can give you partial credit. Multiple choice is either right or wrong, but the way I do most of my tests, if you show your work, I can give you multiple partial credit. So it pays, and especially even test 1, it pays to show your work. Because what happens if you push the buttons wrong here, which I almost did a minute ago? You get 0 if you didn't show your work? Yeah, if you put down the wrong answer. So it always pays on my test, show your work. Oh, let's do one more. This is good for your grade. Also good for you to learn it. Question is, how many moles of Hg, mercury, are 5.934 times 10 to the 51st atoms of mercury? And in important information, you would find this. One mole of an element equals Avogadro's number, 6.02 times 10 to the 23rd atoms of that element. And it's your turn to have some more fun. Have fun. Remember, this material I'm covering right now will be on test 2, not test 1, which I'll be giving tomorrow. Remember, figure out what are you being asked to find unit-wise, what are you given, and then use your good buddy, your good friend, unit analysis. And you don't have to have a calculator, just set it up. If somebody sets it up and doesn't do the actual math, I usually take off 1 point out of 5. So, but you don't want to lose points that easily. But show your work. All right, let me check how you're doing. I'll give you another 30 seconds to finish up, and then I'll do it. Ooh, excuse me. All right, I think that's about it. Let's get going. And the first thing you should do is ask, what are you being asked to find? And how many moles of mercury? What are you given? This. And once you have all this stuff, you don't have to look at this. The other thing you're given an important information. The past, I made students memorize that. Now you'll be given that as 1 mole of an element equals Avogadro's number, 6.02 times 10 to the 23rd atoms of that element. And now it's time to use your good buddy, your good friend, unit analysis. And how do you do that? Well, the only thing I have to start with is this number. So I will. And if I had some magic ratio, what units do I want my answer in? Well, you figured that out up here. And that's moles of mercury. Mercury is Hg. And now it's time to use my good buddy, and hopefully you'll find out it's your good buddy too. Hold on. Uh-oh. I think I know why. Give me 1 second. Uh-oh, this happens once in a while. I've got to close something and I'll open it again. One of these days I'll figure out why that's happening. All right, let's go back here. And yes, I don't know why it freezes up. All right, since I've been messing around Blackboard, and not Blackboard, my whiteboard, everybody see the problem again on your screen? Thumbs up, people, help me out. Thank you. So what do we have to start with this? What are we trying to get to unit-wise? Well, we figured that out right here, moles of mercury. And now I can get my red pen and say, what are we trying to get to when you use your good buddy, your good friend, unit analysis? That goes on top of the ratio. Whatever we're trying to get rid of goes underneath. And I'll write that in. Now, where do I get that? Mercury is an element. 1 mole of an element equals Avogadro's number. Remember, when you have A equals B, there are two ratios you can always have. A over B and, not equal, and two separate ratios, B over A. So if I have 1 mole of a compound, or an element, I should say, in this one, how many atoms do I have? Avogadro's number. And now, before I pick up my calculator, do my units cancel out? Notice this is atoms of mercury divided by atoms of mercury. Anything divided by itself equals the number 1. So these cancel out, and I'm left with moles of mercury, which is what I want. And now I will pick up my calculator, clear it. Don't forget, when you're doing calculations, clear it before you start. And my calculator gives me this answer right down here. So the question is this the right answer? And that's supposed to be a 9. So let's clean this up a little. And the answer is no. And I'm going to let you figure out on your own right now how many significant figures, what should be this answer, and round it off to that. Remember, you get the same number of significant figures in your answer as the number that has the lowest significant figures in your multiplication division. All right, time's up. Let's get to work. How many significant figures here? All non-zero numbers are significant. That's 4 significant figures. How many in Avogadro's number? 3 significant figures. I've seen it on a website somewhere up to 18. Why somebody would use that, I don't know, but 3 is fine. So how do you round this off to 3 significant figures? Keep the 9, keep the 8, keep the 5. Those are my 3 significant figures. Use the next number to round off. Is that 4 or less or 5 or higher? And the answer is 5 or higher. So I'm going to drop all this, increase that by 1, 9.86 times 10 to the 27th, and that was moles of mercury. And that's how you use your good buddy, your good friend, and it's been mine for a long time, unit analysis. And we'll do more of them, but let's move on. Oops, before we move on, I got to open up that file because I had to close it. That's not what I wanted to do. All right, sorry about the technical difficulties. All right, we're back on track now. All right, we've done our mole practice time number 1, including your good buddy, your good friend, unit analysis. So let's move on. And let's talk about molar mass. In your book, it's called Molar Mass, but if you look down here, your instructor will mostly call this in red, the molecular weight, which at times I'll abbreviate MW. Since we all decided earlier this semester that for this summer at least, none of us are leaving the planet Earth, I will be able to interchange mass and weight. And I do. Now, what is the molecular weight of a compound? And the molecular weight of a compound is the sum of all atomic masses or atomic weights of all atoms in the is the molecular weight in the molecular mass And what is the molecular weight? It's the sum of all atomic weights of all the atoms in a molecule. So let's take a look at this. Let's try water. Now, question would be, what's the formula weight or mass, or I will normally put down what's the molecular weight of water. So let's do that. Well, how do you figure out the molecular weight of water? Well, you first determine how many atoms of each type are in the formula, in this case, water. And there's 2 hydrogens and 1 oxygen. Now, the molecular weight is the sum of all atomic weights. So I have to open up a periodic table. All right, thumbs up, people. Does everybody see the green periodic table on the screen right now? Thank you. Now, where do we find the atomic weights? It's the number underneath the element. For hydrogen, it's 1.008. For oxygen, it's 15.999. Now, it's time for a special gift from Dr. White, me. Shh, don't tell anybody I'm being nice. I'll ruin my image around here. For my class, and also when I do it as a chemist, I use all atomic weights to 3 significant figures. I use all atomic weights to 3 significant figures. It makes your life so much easier and you do better on tests. And in real life, it makes your life easier. So my gift to you, and it will say on test number 2 under your name, it will say, please use proper significant figures for all calculated answers. And it will also say, please use all atomic masses to 3 significant figures. So what does that mean? We got to know how to round off things. Hopefully I taught you that. Let me try and move this up. Well, there it is. Why is sound? All right. Now, if we look at hydrogen 1.008, I'm going to let you round that off to 3 significant figures. Then I'll tell you the right number. And the answer is 1.01. Keep the 1, keep the 0, keep the 0. Use the 8 to round off. That's 5 or higher. You drop that, and the number in front, 0, is increased by 1. Why don't you round oxygen off? 15.999 to 3 significant figures. And the answer is 16.0. How'd you get that? Well, you keep the 1, keep the 5, keep the 9. Now, you round, look at the second 9, that's to round off. Is that 5 or higher? Yes. So that 9, the last 9 I drop, and the 9 in front I increase by 1, which is 1.0. 1.0 and 15 becomes 16.0. And that's how you round it off. Now, let's go back. We're trying to find the molecular weight of water. And now we know the molecular weight is the sum of all atomic weights. And for hydrogen, the atomic weight is 1.01. There are 2 of them. For oxygen, it's 16.0. Do the math. Remember, these numbers are exact numbers. So that's 2.02 and 16.0. And since the sum of them, I'm going to add it up, I get 18.02. Now, when you add things, you get the same number of significant figures to the right of the decimal point as the number that has the fewest significant figures to the right of the decimal point. This has 2, this has 1. Zeros after a decimal point are significant. So my answer should have 1 past the decimal. You never do this side to the left. Whatever it adds up, you keep. It took me a while to get my head around this for addition. Multiplications, division, I never had problems with. This one took me a while. Keep this one, use this to round off. It's 4 or less, so the correct answer is 18.0 for the molecular weight of water. And that's how you do it. Oh no, if I look at the clock, we're just about out of time. Boy, time flies when you're having fun with chemistry and Dr. White. All right, remember, tomorrow after the lab, I will be sending out test number 1 password to you. You'll have from 10 until 11:30 tomorrow morning to take test number 1 and upload your answers as a single PDF file to the assignment area Blackboard. If you have any questions or anything, I'm having my office hour. Remember, I changed it from 5 to 6 tonight. And with that, I'm going to say, Gang Gazoon, goodbye. I stole this from the Beverly Hillbillies, and Granny would do this